All right, welcome to section 7.2, sectors of circles. Before we get started, I'm doing this on Sunday, and it looks to me like we don't have school on Monday, so that's definitely a bonus. But we would like to get back to section 7.2. This is called sectors of circles, and we'll learn more about what that actually means. And the objective is to be able to recognize a sector of a circle and to find the measures of an arc length and sector area. So those are the two big things, arc length and sector area. Okay, so let's figure out what those are first. All right, so I have a picture of a circle. Hopefully you know that this is a circle. All right, so I'm going to fill in this point right here. That is the center of your circle. All right. Each one of these arms here will be R. What does little r stand for? Hopefully you know that that stands for radius of your circle. It's the distance from the center to the side of the circle. Let's see here. Okay, this squiggly line here is called an arc. Okay, so that portion of this angle of that circle, that part of the circumference is called an arc. Okay, and let's see what else we can talk about here. This portion that I'm shading in is called a sector, and really it's a piece of pie. Okay, so the piece of pie that we take out of a circle is called a sector. All right, so what else do we need to talk about here? I'm drawing in this is called the central angle. And remember, we're always going to call that theta. Okay, so these are the vocabulary terms that we need to be able to know about sectors and sector area and arc length and arcs. Okay, so we have some formulas here, some equations. Okay, now this looks very difficult to understand. It's really not. Okay, so theta over here can be in two different types of measures. We have degrees and we have radians. Okay, so if your theta is in degrees, you use these top two equations. If your theta is in radians, you use the bottom two equations. Okay, and then here are the two things that we are solving for. Okay, the first one we're solving for is arc length. Arc length, if we notice, is always S. So both of these are S's. Sector area is K, so we're going to use K for sector area. All right, so you shouldn't have to write these down. You have them right here. They're not that hard. Okay, so let's see here. And then at the very bottom, we have this extra equation that we're going to need to use for some particular examples, depending on what we're dealing with. All right, so let's talk about. Let me move this over here. And let's talk about the main letters that we have. Okay, so S stands for arc length. K stands for sector area. Theta is your central angle. And little r stands for radius. And those are the only four letters that you need to know what they stand for, and then you should be able to solve for any of the other letters depending on what you have. Okay, so let's two examples. We're going to do one example where it's in degrees and one example where it's in radians. So I'll be referring back to these equations. All right, so example one. Find the arc length and sector area. Okay, so remember arc length, get used to writing these letters, is S. Sector area is K of the following circle. All right, so if we notice, we are given R equals 12 inches, and we're given theta is 100 degrees. Okay, so we're in degrees, so we're going to use the degree formulas. All right, so let's first do our S formula. Okay, I'll write it over here. S equals theta divided by 360 times 2 pi r. I always put that over 1, so I have two fractions. Okay, let's just fill in everything that we know. So S equals, what's theta? 100 over 360 times 2 times pi times r. What's r? R is 12 times 12 divided by 1. Okay, and then let's cancel what we can cancel. If there's nothing we can cancel, then we'll move on. But there should be some things that we can cancel out first. All right, so equals. All right, so divide both of these by 10. That works. Get rid of the zeros. Half of 10 is 5. Half of 36 is 18. All right, we can cancel a 2 out here. 2 goes into 2 once. 2 goes into 18 9 times. I have a 12 and a 9. 3 goes into 9 3 times. 3 goes into 12 4 times. And it looks like we're pretty much done now. So on top, what do I have? I have 5. So let me circle what we have left. I have 5 times pi times 4, which is 20 pi, over, and on the bottom I have a 3 times a 1, which is 3. So my arc length is 20 pi over 3, and look at our unit is inches, so I need to add a length in there. Okay, so basically just one big multiplying problem. All right, now let's do k. K is basically the same thing. All right, let me change my marker here. So k is equal to theta over 360 times pi r squared over 1. Just going to add that 1 over it. All right, let's fill in everything that we know. Let me extend the page here really quickly. All right, so k equals theta is still 100 over 360 times pi times r squared. R was 12, so I have 12 squared over 1. All right, let's see here. So k equals 100 over 360 times 12 squared is 144 pi over 1. All right, so let's start canceling. So divide both by 10. Zeros go away. Half of 10 is 5. Half of 36 is 18. Half of 18 is 9. What's half of 144? 72. Okay. 9 goes in 9 once. 9 goes into 72 8 times. Okay, and I think we're all simplified here. So let's circle what we have left. We have a 5 times 8 times pi, which is 40 pi. On the bottom I have 1 times 1, which is 1. Do I need that over 1? No. So this is equal to, oops, what happened there? Get rid of that, 40 pi. And what's our unit? This isn't, remember, K stands for area, so we need to use our unit squared, so it's inches squared. Okay, so those are our two formulas. S was 20 pi over 3 inches. K was 40 pi inches squared. Okay, so that example is when you are in degrees. Okay, now let's do example 2. Okay, it says find arc length. Remember, arc length is S. Find sector area, that's K. And now we are in radians, so we need to do our radian formulas. So let's do the first one. S equals, and if we go back to our chart, radians, S equals R times theta. Okay, so S equals R times theta. This one is much easier to do. So R is 6. Theta is 2 pi over 3. Let's put 6 over 1. Let's reduce. 3 goes into 3 once. 3 goes into 6 twice. So on the bottom I have 1. I don't need to write that. On top I have 2 times 2 pi, which is 4 pi. And what's our unit? Centimeters this time. So S equals 4 pi centimeters. Okay. And lastly, let's do K. And if we go back to our cheat sheet here, K is 1/2 times R squared times theta. Oops. K equals 1/2 times R squared times theta. Okay, so let's fill in everything we know. We know 1 over 2 times R squared. R is 6, so 6 squared is 36 times theta, which was 2 pi over 3. Okay, so all I have now is a couple 3 fractions. 2 over 2 cancels. 3 goes into 3 once. 3 goes into 13 12 times. And let's see here. We have 1 times 12 times pi, which is 12 pi. On the bottom, I have 1 times 1 times 1, which is just 1. And remember, K is an area, so I need to add a squared to it. Okay, so radians is actually easier to use. Okay, but you can do it both ways. All right, so 4 pi centimeters, and K is 12 pi centimeters squared. All right, now, last example. It says a sector area of a circle has an arc length of 6. Okay, so let's basically, for this one, we're not trying to find arc length and area. We're trying to find the radius and central angle. So let's list our letters. We know we need an S. We know we need K. We know we have an R. We know we have theta. Okay, let's figure out what our two knowns are. It says we have an arc length of 6 centimeters. Arc length is S, so I'm going to add that in there. So we know S. All right. Now, we also know, and an area, so we have an area of 75 centimeters squared. So we already know S and K. We now need to find R and theta. All right. So what we need to do is find an equation that has S and K in it, and doesn't have one of these two. Okay. So if we go down here, we see this formula has S and K. We know that, and then we should be able to find our R. Okay, so this is the one we're going to use. K equals 1/2 RS. So K equals 1/2 RS. Let's fill in what we know. We know K is 75. 1/2 times radius we do not know. Over 1, I'm going to put that on 1, times S, which is 6 over 1. All right, so let's see what the right-hand side is equal to. 75 equals, on top we have 6R, on the bottom we have 2. 2 times 1 times 1. So really we have 75 equals 3R because 6 divided by 2 is 3. Okay, so what's my R? Divide both sides by 3. R is equal to 25. So remember, what's our unit for radius? If this says centimeters squared, then our radius would just be centimeters. Okay, so there is our one answer that we need. Now we need theta. But we have S, we have K, we have R. So if we go back to our formulas, if we already know S, K, and R, and we need theta, let's look at these equations and notice that this equation right here. We know S and we know R. We should be able to figure out theta pretty easily. So we're going to do S equals R theta. Okay, so down here, S equals R times theta. We know S. What's S? Go back up here. S is 6 centimeters. Equals R. We just figured out R. R is 25 times theta. So we have to divide by 25 to get rid of it. So theta equals 6 over 25. Now, can we reduce there? Is there anything that will go into both 6 over 25? So if not, I would probably just leave it. 6 over 25, or let's get a decimal for that. 6 divided by 25 is 0.24. 0.24. Okay, so we're in 0.24. Now, what formula did we just use there? We did S equals R theta, which is a measurement in radians. So I would probably add radians to this answer. So 0.24 radians, or 6 over 25 radians. Okay, so that's the section 4 sector area and arc length. Pretty easy, as long as you know these 4 formulas. Okay, so you need to know, definitely need to know these 4 formulas, and the one on the bottom can go for any of these. All right, so that's it. I will see you tomorrow. Enjoy your day off. I won't see you tomorrow, but enjoy your day off. We might have one on Tuesday as well. We'll get to this as soon as we can. Have a good day, have a good night, enjoy the weather, stay warm.